Day 17 of 90, and today we're tackling the thing that quietly runs every Go service in production: packages and modules. If you came from GoPath, you remember the pain projects had to live in one magic directory, and dependencies were a guessing game. Modules killed that. By the end of these 5 minutes, you'll structure a real microservice, develop 2 modules side by side without faking versions, and lock down your builds so a colleague's checkout never breaks. Let's go. First, why modules exist: reproducible builds and real versioning. You start one with a single command, go mod init github.com/u/orders single quote. That writes a go.mod file with your module path, your Go version, and a require list. Treat go.mod as a contract, not a config file. When you add a dependency and run your code, Go records the exact version and a checksum in go.sum. That checksum is what guarantees the bytes you built today are the bytes your teammate builds tomorrow. Now let's split a service cleanly. A production layout looks like this: cmd/server holds main, the entry point. Internal/handler owns HTTP transport. Internal/store owns persistence. The package name comes from the folder, and capitalization is your access control. An exported type starts uppercase, like type order struct. Lowercase means package private. So your handler can call store a save, but it can never touch store's internal connection pool. Visibility isn't a style guide here, it's the compiler enforcing your layers. The internal directory is the real magic. Anything under internal can only be imported by code rooted in the same parent. So github.com/u/orders/internal/store is reachable from your CMD and handler packages, but if another module tries to import it, the build fails, use of internal package not allowed. That's a hard guardrail. It means you can refactor everything inside internal freely, because no outside team could have depended on it. Put your public, reusable API in package, put everything you want to keep private in internal. Here's a daily pain fix: you're building a service and a shared Kit library at the same time. The old hack was pushing fake tags to a registry just to test a change. Don't. Use workspace mode. Run go work init/kit/orders and go writes a go.work file listing both modules. Now when orders imports the Kit package, the toolchain resolves it to your local folder. Your unsaved, uncommitted edits compile instantly across both. No replace directives, no version churn. And crucially, go.work stays out of version control, so it never leaks into anyone else's build. When you do need a temporary swap inside one module, that's the replace directive: go mod edit replace github.com/acme/http client =:http client-fork single quote. Great for debugging a third-party bug against a local fork. But say it with me: every replace you leave in is technical debt. Before you merge, remove it and pin a real version. Go get github.com/acme/http client at v1.4.2 single quote. A stray replace directive is the classic Friday afternoon landmine that breaks a colleague's build when they don't have your local folder. Finally, the 3 commands every CI pipeline needs. Gomod tidy adds what you actually import and removes what you don't. Run it and your go.mod stops lying. Gomod verify confirms every dependency in your cache matches its recorded checksum, so a tampered package gets caught. And gomod vendor copies all dependencies into a local vendor folder. Build with mod equals vendor and your Docker image compiles with 0 network calls, hermetic, reproducible, and perfect for air-gapped CI. Day 17 done. The takeaway: go.mod is a contract, internal is free architecture enforcement, and workspace mode lets you develop modules together without faking versions. Master these and dependency chaos stops killing your team's velocity. Subscribe for day 18.